We're often told that humans are social creatures, but this vastly understates the reality. Our brains aren't just influenced by social connection, they're fundamentally built for it. Every aspect of human consciousness, from our earliest moments to our final breaths, is profoundly shaped by our connections with others. Let's start with a remarkable fact. Your brain uses the same neural circuits to process physical pain and social rejection. When someone says their feelings are hurt, they're describing something literally true at the neural level. This isn't a coincidence. It's a clue to how deeply social connection is wired into our biology. Our social nature begins before birth. A developing fetus already responds to the mother's voice, and newborns prefer their mother's face to any other stimulus. This instant social orientation isn't learned. It's built into our neural architecture. Within hours of birth, babies are already imitating facial expressions, participating in a primitive form of social connection that will develop into increasingly sophisticated forms of interaction. The evolution of our social capabilities is a fascinating story. Our ancestors faced a crucial challenge: how to coordinate and cooperate in larger groups than any other primate. This pressure led to the development of increasingly sophisticated social abilities. Our larger brains, particularly the expanded prefrontal cortex, evolved primarily to handle the complexity of social relationships. The human brain devotes an extraordinary amount of resources to social processing. We have specialized neural circuits for recognizing faces, interpreting emotional expressions, understanding others' actions, and predicting their thoughts and feelings. The temporal lobe contains regions specifically dedicated to processing faces, while the superior temporal sulcus helps us interpret others' movements and intentions. Consider the mirror neuron system, a network of neurons that fires both when we perform an action and when we watch someone else perform the same action. When you see someone smile, your mirror neurons activate as if you were smiling yourself. This system provides the neural basis for empathy, allowing us to literally feel what others feel. Our brains are so deeply social that they actually synchronize with others during interaction. When two people engage in conversation, their brain waves begin to align in a phenomenon called neural synchrony. Musicians playing together, mothers comforting their babies, even audiences watching a performance, all show patterns of brain synchronization that reflect our profound capacity for connection. The social nature of our brains explains why isolation can be so devastating. Extended solitary confinement isn't just unpleasant, it causes actual brain damage. Studies show that social isolation is as damaging to physical health as smoking 15 cigarettes a day. Your brain interprets social connection as a fundamental survival need, not a luxury. Let's explore how early social experiences literally shape our developing brains. An infant's brain more than doubles in size during the first year of life, and this growth is profoundly influenced by social interaction. When a baby locks eyes with their caregiver, it triggers cascades of neurochemicals that stimulate neural growth and pruning. This delicate dance of interaction shapes the very architecture of the developing brain. The science of attachment reveals something fascinating about how our early relationships create lifelong patterns. When a caregiver consistently responds to an infant's needs, it establishes secure attachment. But this isn't just a psychological phenomenon. It actually shapes the development of the hippocampus, which regulates stress responses and emotional memory, and the amygdala, which processes emotional reactions. Consider what happens in the brain during early social learning. When a baby sees their mother smile, multiple brain systems activate simultaneously. Visual areas process the facial expression, mirror neurons simulate the smile, emotional centers respond with pleasure, and memory systems store the experience. This complex neural choreography helps explain why early relationships have such lasting effects on personality and behavior. The development of social memory is particularly intriguing. Your brain has specialized systems for remembering faces and social information that are separate from other types of memory. You're more likely to remember someone's role in your social network than other details about them, a reflection of how our ancestors needed to track complex tribal relationships for survival. Culture profoundly shapes this developmental process. Studies across different societies show that while the basic building blocks of social cognition are universal, the expression of social behavior varies dramatically. Children growing up in collectivist cultures, for instance, develop different patterns of brain activation during social tasks compared to those in individualistic societies. The role of play in social development can't be overstated. When young children engage in pretend play, they're actually training sophisticated social cognitive abilities. Role-playing activates brain regions involved in understanding others' perspectives, a crucial skill called theory of mind. This explains why play deprivation can have serious consequences for social development. Social learning extends far beyond childhood. Throughout adolescence, the brain undergoes another massive reorganization, with social experiences playing a crucial role. The teenage brain is exquisitely sensitive to peer influence because it's building the neural architecture that will support adult social relationships. Status and hierarchy awareness emerges early and remains a fundamental aspect of social cognition. Even very young children show brain activation patterns indicating sensitivity to social status. This reflects our evolutionary heritage. In our ancestral environment, understanding and navigating social hierarchies was crucial for survival. The development of empathy follows a fascinating trajectory. While the basic capacity for emotional contagion is present from birth, the sophisticated cognitive empathy that allows us to truly understand others' perspectives develops gradually through childhood and adolescence. This development depends on a complex interplay between genetic predisposition and social experience. Language acquisition provides another window into our social nature. Babies learn language not just by hearing words, but through social interaction. The motherese that adults instinctively use when talking to babies is perfectly tuned to help developing brains extract linguistic patterns. This explains why screen-based language learning is far less effective than face-to-face interaction. The adult brain remains profoundly social, with our social connections influencing everything from stress responses to cognitive performance. Let's explore the fascinating neuroscience of adult relationships, starting with romantic love. When you fall in love, your brain goes through changes remarkably similar to addiction. Brain imaging studies show activation in the nucleus accumbens, the reward center, along with drops in serotonin levels similar to those seen in obsessive-compulsive disorder. This helps explain why new love can feel so all-consuming. But as relationships mature, the brain shifts from these intense reward circuits to systems associated with attachment and bonding. The neuroscience of friendship reveals equally fascinating patterns. Close friendships activate brain regions associated with self-referential thinking. You literally process a close friend's experiences as if they were happening to you. This explains why genuine friendships have such powerful effects on health and well-being. Studies show that strong social bonds reduce inflammation, improve immune function, and even increase longevity. Group dynamics tap into ancient neural circuits that evolved to help our ancestors survive in tribes. When you're part of a group, your brain processes threats to the group as personal threats. This explains phenomena like sports team loyalty. Your brain literally treats your team's success or failure as your own. The same mechanisms can drive darker phenomena like intergroup conflict and prejudice. Social status profoundly affects brain function. Even subtle changes in perceived status alter hormone levels and neural activity patterns. When you feel respected by others, your brain releases serotonin, which influences everything from mood to decision-making. Conversely, perceived loss of status triggers stress responses that can impair cognitive function. The workplace provides a fascinating laboratory for studying social brain function. Office politics aren't just an annoyance. They engage the same neural circuits our ancestors used to navigate tribal hierarchies. Understanding a colleague's intentions activates regions in the prefrontal cortex involved in social prediction, while workplace rejection activates pain centers, just like physical injury. Cooperation and competition engage distinct neural networks. When cooperating, brain regions associated with reward and social bonding activate. During competition, regions involved in strategic thinking and threat assessment become more active. This dual capacity for cooperation and competition gave our ancestors a crucial evolutionary advantage. Social decision-making involves sophisticated neural computations. When deciding whether to trust someone, your brain integrates multiple streams of information. facial expressions, past experiences, social context, and subtle behavioral cues. This happens largely unconsciously, which is why we often have gut feelings about people before we can explain why. The phenomenon of social facilitation, performing better when others are present, has clear neural correlates. The presence of others increases activation in brain regions associated with attention and effort, explaining why we often perform better when being watched. However, this same mechanism can lead to choking under pressure when the social stakes are too high. Social memory in adulthood shows interesting biases. We're better at remembering information that's relevant to our social relationships than other types of information. Your brain pays special attention to social betrayal, a reflection of how crucial group loyalty was for our ancestors' survival. The brain's capacity for social learning continues throughout adult life. When we observe others succeeding or failing, our brains encode these experiences almost as if they happened to us. This vicarious learning engages mirror neuron systems along with regions involved in abstract reasoning, allowing us to learn from others' experiences without having to make every mistake ourselves. The digital revolution has created an unprecedented experiment in human connection. Our social brains, evolved for face-to-face tribal living, are now attempting to navigate a world of virtual relationships, social media feeds, and constant digital connection. This mismatch between our ancient social circuits and modern technology is revealing fascinating things about how our brains process social information. Social media platforms tap directly into our brain's social reward circuits. Every like, share, and comment triggers a small dopamine release, the same neurotransmitter involved in all rewarding experiences. But there's a crucial difference. Natural social interaction provides a mix of neurochemicals, including oxytocin and endorphins, that create deeper satisfaction. Social media often gives us a hollow dopamine hit without the full spectrum of neurochemical rewards our social brains crave. The phenomenon of social snacking, brief, superficial social interactions, has increased dramatically in the digital age. While these quick social hits can temporarily satisfy our need for connection, brain imaging studies show they don't activate the neural networks involved in deep social bonding. It's like eating junk food when your body needs nutrients. It might temporarily satisfy hunger, but it doesn't provide what your brain really needs. Online communication lacks crucial social signals our brains evolved to process. In face-to-face interaction, we unconsciously track dozens of signals, minute changes in facial expression, tone of voice, body posture, personal scent, and even subtle variations in skin conductance and heart rate. These signals help us build trust and empathy. Without them, our social brains often fill in the gaps, sometimes inaccurately. The impact of smartphones on social behavior is particularly striking. When a phone is visible during a conversation, people show reduced neural synchrony, the brain-to-brain coupling that occurs during deep social connection. Even if the phone is never touched, its mere presence signals potential social competition, activating ancient circuits that monitor for threats to social bonds. Virtual reality and augmented reality present new challenges and opportunities for our social brains. Early research shows that VR can trigger genuine social responses. Our brains process virtual faces and bodies using many of the same circuits we use for real social interaction. However, subtle differences in how we process virtual versus real social cues might have long-term effects we don't yet understand. The phenomenon of context collapse in social media, where updates are broadcast to our entire social network simultaneously, creates unique social stress. Our brains evolved to navigate different social contexts separately, adjusting our behavior for different social groups. When these contexts collapse together, it triggers anxiety circuits in ways our ancestors never had to deal with. Working remotely through digital tools has revealed interesting things about how we process professional relationships. Video calls create what researchers call Zoom fatigue. Our brains work harder to process social cues through screens, leading to mental exhaustion. The slight delays in digital communication can disrupt the natural rhythm of turn-taking in conversation, creating subtle but persistent social stress. The impact of digital technology on developing brains is particularly concerning. Children growing up with tablets and smartphones show different patterns of social skill development compared to previous generations. While they might be more adept at certain types of digital interaction, Some studies suggest they may struggle more with reading facial expressions and navigating in-person social situations. Understanding how our social brains function allows us to make more conscious choices about how we connect with others. Let's explore practical strategies for nurturing healthy social connections in our modern world, based on what neuroscience has revealed about our social needs. Quality of connection matters more than quantity, and this shows up clearly in brain imaging studies. A single genuine conversation triggers more positive neurological changes than hours of social media browsing. When people engage in deep, meaningful interaction, their brains show increased activation in regions associated with reward, empathy, and social bonding. This explains why you can feel lonely despite having hundreds of online friends. The concept of social fitness deserves as much attention as physical fitness. Just as your body needs regular exercise, your social brain needs regular, meaningful connection. Studies of blue zones, areas where people live unusually long, healthy lives, consistently show that strong social bonds are a crucial factor in longevity. Social interaction stimulates the production of neuroprotective hormones that can actually slow brain aging. Touch is a crucial element of social connection that our modern world often lacks. Physical touch, whether a handshake, hug, or pat on the back, releases oxytocin and reduces cortisol levels. This explains why physical isolation during the pandemic was particularly challenging for mental health. The neuroscience of touch reveals why digital connection alone can't fully satisfy our social needs. Our brains process physical touch through specialized neural circuits that respond differently than other forms of social interaction. Building strong relationships requires vulnerability, something our brains often resist because it triggers threat responses. But brain imaging studies show that moments of shared vulnerability activate neural networks associated with trust and bonding. When you share something personal and receive understanding in return, it creates lasting changes in how your brain processes social trust. The power of ritual and social bonding has deep neurological roots. Whether it's a regular family dinner, weekly game night, or annual celebration, social rituals create predictable patterns of interaction that help our brains build stronger social connections. These ritualized interactions show distinct patterns of neural synchrony compared to casual social contact. Group size matters more than we realize. Dunbar's number, the cognitive limit to the number of people with whom we can maintain stable social relationships, isn't just a theory. Brain imaging studies show that regions involved in social cognition become overwhelmed when trying to process too many relationships. This explains why trying to maintain too many active social connections can lead to social exhaustion. Understanding your personal social needs is crucial. While we're all wired for connection, we vary in our optimal level of social interaction. Introverts and extroverts show different patterns of brain activation in social situations, and even different baseline levels of dopamine sensitivity. The key is finding your personal balance between connection and solitude. The role of storytelling in social bonding reveals something fascinating about how our brains process shared experiences. When people share stories, their brain activity begins to synchronize, creating a literal meeting of minds. This explains why shared experiences, whether through conversation, activities, or even watching a movie together, create stronger social bonds than parallel but separate experiences. Cultural practices around social connection show remarkable wisdom when viewed through the lens of neuroscience. Many traditional societies have customs that regularly bring people together for shared meals, storytelling, or celebration. These practices aren't just pleasant customs, they're sophisticated systems for maintaining the kind of regular, meaningful social contact our brains require for optimal function. As we wrap up this exploration of the social brain, remember that your need for connection isn't a weakness. It's your fundamental nature as a human being. In a world that often prioritizes individual achievement and digital efficiency, understanding our deeply social nature can help us create lives that better align with our brain's true needs. This capacity for deep social connection, shaped by millions of years of evolution, is one of humanity's greatest strengths. Whether through technology or face-to-face interaction, the key is fostering genuine connection that satisfies our fundamental need to belong. Your brain developed its remarkable social capabilities for a reason. They're essential to not just your happiness, but your very survival. In our next episode, we'll explore another fascinating aspect of human experience: how we perceive and process time, and what this reveals about consciousness itself. Until then, pay attention to your social connections, both online and off. They're not just pleasant additions to life, they're essential to who you are as a human being.